Hi there, in this video we're going to talk about how to solve a two-step equation. So what does that even mean? That means that you're going to have an equation and you want to get the variable on a side by itself using two operations, two steps. So remember, operations, we are just looking at addition, subtraction, so addition, subtraction, multiplication, or division. So we want to just review one math idea, well actually three math ideas, before we go in and solve some two-step equations. So the first thing that we want to remember is order of operations. Please excuse my dear Aunt Sally, which remember stands for parentheses, exponents, multiplication and division, addition and subtraction. Next, we want to remember that addition and subtraction undo each other, and multiplication and division undo each other. So those are our three ideas. And now we're going to get kind of going right into the lesson about how this works. So when you're using or solving an equation with two operations, how do you know which operation you undo first? We're going to use PEMDAS except in reverse. So first, anything that's added or subtracted to my variable, I'm going to move. Then I'm going to move anything that's multiplied or divided. So let's give it a shot. So I want to solve. First thing I'm going to do is I'm going to put a line right down my equals. So I remember whatever I do to one side of the equation, I'm going to do to the other. Okay, so here's the variable that needs to get on a side by itself. I have to move the 3 and I have to move the 7. Okay, so when I'm using this StraightMath, I don't have a good way to remember that, just PEMDAS in reverse. Okay, I have to move anything that's added or subtracted to my variable. So the 7 is what I'm adding or subtracting. The 3 is something that I'm multiplying. So that means I'm going to move this positive 7 first. And so I'm going to ask myself the question, how do I undo positive 7? Well, adding 7, I subtract 7 from both sides, because remember, subtraction undoes addition. So 7 minus 7 goes away, and I'm left with 3x equals 19 minus 7, which is 12. Okay, now I have to undo this 3. Now, does this 3x, does that mean 3 plus x, 3 minus x, 3 times x, or 3 divided by x? It means 3 times x. So how do we undo times? Remember, multiplication and division undo each other. So I'm going to divide both sides by 3. So 3 divided by 3 is 1, cancels each other out. So I'm left with x is equal to 12 divided by 3, which is 4. Now you can go back and check this to see if it's correct. So on my check, I'm going to plug in, wherever I have an x, I'm going to plug in 4. So this is going to say 3 times 4 plus 7 equals 19. And then I'm going to use my order of operations in the proper order. So I'm going to multiply first, 3 times 4, which is 12. And 12 plus 7 is 19. So I get 19 equals 19, and that is correct. Okay, let's go on again. Now this one's a little trickier. This one says 10 equals 7 minus m. I look at this and I think, well, it really only looks like I have one step. Here's the tricky part though. When I'm subtracting here a variable, this is like, well, there's really a negative 1 in front of it. So it really looks like 10 equals 7 minus 1 m, like this. Okay, so let's solve. I'm going to draw my line down the equals so that I remember to do my things to both sides. And my numbers that I have to move are 7 and negative 1. Now remember the rule, I have to move anything that's added or subtracted to the variable first. Now it looks tricky written this way. So if I rewrite my whole equation, I'm going to flip it around and I'm going to manipulate it so it looks a little different so you can see what I'm working with. So this is a negative 1m plus 7 equals 10. Now you might ask me how I did that. I can switch the order of things that I add, because think about it as 1 plus 2 is 3 and 2 plus 1 is also 3. I can change the order on how I add things and it doesn't change my answer. So I flipped these around. And I like to have my variable on the left, so I flipped around also my equation around my equals. So now I'm going to solve it like this. This is going to look a little bit more familiar to you. So we're not going to worry about this part over here, because now I rewrote it on this right side so that you can see that I have this -1 and I have this 7. So what am I adding or subtracting to my variable first? I'm adding 7. So the 7 is the thing that I have to move first. So what undoes positive 7? Or what does adding 7? Subtracting 7. So I'm going to subtract 7 from both sides. So I get -1m equals 3. 10 minus 7 is 3. Now I have to move this -1. So this says -1 times m. So what undoes multiplication? Division. So I'm going to divide both sides by -1. So my -1's cancel out and I get m is equal to -3. Now you might look at this and say, well, if -m is equal to +3, then positive m is equal to -3. You can also think about it that way. And you can go ahead and check this just like we did the first one. Okay, next. I'm going to put a line down my equation so I remember to do everything to both sides. So I have two things I have to move. Here I have a 5/6 and here I have a -8. We want to move anything that's added or subtracted to my variable first. So what's added or subtracted to my variable? The -8. That's what I'm going to move first. What undoes -8 or subtracting 8? Adding 8. So I'm going to add 8 to both sides. This cancels out, so I end up with 5/6 c is equal to 15. Okay, now I have to get rid of this 5/6. Okay, now when I have a fraction that's multiplied by my variable, I can do one of two things. I can divide by my fraction, but dividing by a fraction, because this is 5/6 times c, so remember dividing undoes multiplying. But when I have a fraction, I can also use the reciprocal. I can multiply by the reciprocal, which means I take my fraction and I flip it over. The reciprocal of 5/6 is 6/5. Why does that work? Because 6/6 cancels each other out, it equals 1, and 5/5 cancels each other out, it equals 1. So whatever I do to one side, I have to do to the other side. Okay, so now I get 15 times 6 divided by 5, and I can actually use what's called, remember, if we use our order of operations, we said that multiplication and division, I can do it in any order, right? So I'm going to do the division first because it's going to make my number smaller. So I'm going to do 15 divided by 5 first, and that's going to give me 3, and 3 times 6 is going to give me 18. So 18 is going to be my final answer. And last but not least, this one looks a little bit different, but it still is 2 steps. And the reason is this. On my left-hand side, notice here I have 11x and here I have -9x's. These are considered like terms because this one has an x and this one has an x. So I first have to simplify 11x minus 9x before I can do anything else. So 11x minus 9x is equal to 2x. How did I get that? Think of x's like xylophones. If you have 11 xylophones and you take away 9 xylophones, you have 2 xylophones left. So I get 2x is equal to 16. Now 2x, remember that means 2 times x. So division undoes multiplication. So I'm going to divide both sides by 2. 2 over 2 cancels each other out, equals 1. So I get x is equal to 16 divided by 2, which is 8. Let me know if you have any questions. Good luck.